Greetings, and welcome to Eureka Math Squared. This is grade 6, module 3, I believe, lesson 13, and this is all about constructing the coordinate plane. This is a difficult lesson. I'm not going to tell you this is super simple because I just don't think it is. However, it is definitely doable. I have a couple of tricks that are going to help you out a little bit. Now, this lesson is all about what happens if your values aren't so fun to work with. So you get your ones and your twos. That's super nice, right? And well, that would be a great thing, but that's not always the case. So let's cruise down here like this guy. See, this is a nice deal. If I'm trying to plot some points and I have a 0, a 4, a -5, a 2, a -2, a 0, a -4, and a 5, I can go ahead and use what is called an interval of 1. Okay, an interval of 1. And what that means is that I can just count every box as 1, right? 3, 4, 5, 6, 7, 8, 9. I don't have to worry about it. Everything will work out wonderfully well. Look at the y values, a 4, a 2, a 0, a -1. They're very friendly. So if I'm just putting using an interval of 1, so there's a -2, a -3, a -4, and so on, everything fits inside the grid and everybody is happy and no one is frustrated. However, what happens if these numbers aren't so friendly to work with? What happens if you have a value that's higher than 10, right? Well, these values only go as high as 10 or negative or as low as -10, but what happens if they have an absolute value that goes beyond the +10, an absolute value that goes beyond the 10 in the negative area, yada, yada, yada. Well, if that's the case, well, we're going to have to change our intervals. So what I did was I would have cruised down to page 169 because I found one. We're going to play around in here. And this is what I'm talking about. See, the x value 10 is not so bad. That would have fit on that earlier grid. But this -70, no way, that's not going to work. We also have a 0, a -15, and a 25. So I'm going to have to check and change my x interval, right? My little intervals, right? And I'm going to have to check and adjust my y intervals. Okay, look at my y's. These guys are huge, great absolute value there. -70, that has an absolute value of 70. Look at that, right? Absolute value of 70. That's big. But look at my y's. My y's are tiny. The biggest absolute value I have is this guy here, which is a 4.5. So here's the trick, folks. Here's what you want to do. Well, first I want to find out how many boxes I have to work with. So if I put let's see, my origin in the middle here. Let's see if I did this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, so far, so good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Not that you have to have this guy in the middle, but it kind of helps out. So I'm assuming this guy is going to be fine as well. So let's just draw these out. Oh, that's terrible. Sorry. Put these out here. Let's get my x-axis set and my y-axis set. Here. Ooh, that's just really shaky. Sorry. There's my y-axis. If you're working with paper, definitely use a ruler. All right, so here's the deal. Let me get rid of all this. So I have 10 boxes to work with. That's important because sometimes you don't always have 10 boxes. Maybe you have more boxes to work with. Maybe you have fewer. But I have 10 or even 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so even 11. But no, let's just use 10. And if I need the extra box, I get it. So here's what you do. You check out your x values. What you're looking for is the greatest absolute value. Find the highest or greatest absolute value, right? For just the x's, there we have these guys right here. 0 clearly is not the greatest, but there it is, that -70, right? That -70, there it is, which means my absolute value is 70. Now here's what I like to do. I'll take that 70 and I'll divide it by the amount of boxes I have, okay, to work with. So if I have 10 boxes, I really have 11, but let's say I have 10. I get 70 divided by 10 as 7. So that means I can take each of these guys and start counting by sevens, right? 7, 14, 21. But just hold on a second here. If I take that 7 and then just compare it to these guys here, I realize that, sure, I can plot this one well and this one well, but these other guys are going to be a little bit of an issue. So what I'm going to do is just round this and find a nice friendly number that's close to 7 that I can use so that I can easily, or more easily at least, plot these values. And I realize that looks like 10 is going to be a good number. You don't want to round down because then you won't have enough room. But if you round up, then you'll definitely have enough room for every x value. So I'm going to use 10. What I mean now, what happens is, not what I mean by, but what happens is, my interval is now set as 10, so every box is now worth 10. Now, I don't think I really want to put a number in for each of these guys. It'll just be so crowded. So let's do 10, 20, 30, 40. I'll just put a 50 there, 60, 70, 80, 90, and I'll put a 100 there. Okay, and I'll get rid of these other two. So it's obvious that every box is worth 10. And I'll do the same thing on the other side. 10, let's see, a negative 10, a negative 20, a negative 30, a negative 40, negative 50. There it is. A negative 50, negative 60, negative 70, negative 80, negative 90, negative 100. Okay, so that's my x value, right, or my x interval. The y is going to be different. Now, they can be independent. They don't have to be the same thing. So now I'm going to do the same thing with my y interval. And again, I'm going to look for the highest absolute value, right? The highest absolute value, the furthest away from 0. And it looks like this 4.5 is the furthest away. So my absolute value of 4.5 is actually, well, 4.5. And if I divide that by 10, right, because I still have the 10 boxes. I know this sounds kind of complicated, but it goes pretty quick, actually. I wind up with 0.45, which is super close to 1/2, right? 0.5, which is really 1/2. So that's what I'm going to use for my y interval, 0.5 or 1/2. So that means every box is worth 1/2. So if that's worth 1/2, then that's going to be worth 1 whole. That means that's 2, 3, 4, 5. See? Every box is worth 1/2. And I'll do the same thing down here. -1, -2, -3. And again, I don't have to put a value in for each of these, but it's spaced out pretty well. So it's looking like that that's okay. So now that I have my interval set, I can begin plotting. So to release my confusion over here, I'm just going to erase what I have. And so now I can plot a 10 for the x, or 10 right, 3.5 up. So let's see, 10 is going to be right there, and then 3.5, right there. See? And I'm just going to put my A right there. And now for my next guy, -70, which means left 70, which is going to be -50, -60, -70, right about there. And then down 2 whole, right? Down 2. There you go. I can put those in there, just like that. And there's point B. Okay? So if I want to put the ordered pairs in, so this is a 10, positive 10, and then a positive 3.5. There it is, right? And over here was a -70, and down, so -2. And I always like to put my little quadrants in here. My quadrants and my values, my x and y values. So my x will always be a negative here, my y will always be a positive over here. Quadrant 3 will be 2 negatives, a negative x and a negative y. And quadrant 4 will be a positive x and a negative y. Just so things match, right? So if I have 2 negatives, I know I'm in the right spot. If I have 2 positives, I know, again, I'm in the right spot. And I can keep going. So here's a 0, -1.25. Now, careful here, a -1.25. This is -1.5. -1.25 is going to be in between that. So he's going to be hanging out over here. He's really small. Tough spot right there. Okay. Oh, wait a minute, he's in the wrong spot. 1.25, so that's not right. Let's see, he's close. 1.25, so if this is negative 1.5, negative 1.25 is there. There he is. Right in between negative 1 and negative 1.5. So point C, and so that's a 0, negative 1.25, like that. There he is. Okay. Next one would be a negative 15, right? A negative 15. Right, negative 10, negative 20, negative 15 is right there. And then a 4.5. Let's see, a 4.5. That's nice. Right about there, right? 4.5. That's a positive. Should be right there, right in the middle. There you go. There's a D, point D, and he is a negative 15, right? And in the second quadrant, and a 4.5. All right. And then in point E will be a positive 25, which is right in the middle. See how nice and easy this is to plot? If that's a 50, it's right in the middle. So he's going to be right there at 25. And then a negative 0.75, which if that's a negative point, he's probably going to be right about there. He's going to squeeze himself right into that spot right there. There he is, point E. And gosh, I'm running out of space here. There it is. So 25 on the X. And it looks like a negative 0.75 on the Y. There you go. All right, so there's the deal, or that's the deal. Make sure that you're counting your boxes, finding those highest absolute values, and then dividing by the amount of boxes you need to decide your interval. Once you have your interval set, you could then plot where you need things to go. Okay, so and I guess the other rule of thumb is try to use as much of the grid as you can, right? Because you don't want everything just cluttered into a small area here. It's so hard to read. So if you can expand things out, right, by finding the largest interval you can and still everything fit on the grid, you'll be better off. All right, so that's the deal, folks. I hope you enjoyed that. Remember, math rules. Have a great one. Take care. Bye-bye.